was made to help the students of standard 9th with their maths, and especially the students who are studying under the Maharashtra state board, because I am going to follow their practice set. Okay, so the first chapter of your maths subject is set theory. So let's start with the definition. In simple words, set is sort of a collection. Can any collection form a set? Definitely not. So to make the difference, okay, first consider two cases. List of students of my class. Okay, assume that I am a class teacher and I am making list of students of my class, and then next is the list of smart students of my class. Okay, let's choose, I choose two students from my class and I ask them to make the list of students of their class. Okay, so they both will come up with the same list provided they don't make any errors. Okay, so two different people are making the list and they will come up with the same list when they make the list of students of my class, right? So this will form a set because the elements in that particular collection is well defined. It is just the students of my class. That's just that rule they have to follow. Next, consider the next case, list of smart students of my class. Now if I pick any two students and tell them to make the list of smart students of my class, they will come up with totally different list. They might write the name of their friends, they may write their own name, or they just may come up with a list which is that no one is smart in the class, ma'am, they might tell. So smartness, now this is a relative term. This will differ from person to person about whom they think they are smart. So this cannot form a set because the members of this particular collection are not well defined. Whereas here it is well defined because anyone will make this list. They have to come up with the same list of students. And if I keep the class is fixed, okay, then. But whereas smartness of person, we cannot decide. So this is not a well defined collection. Okay, so this won't form a set and this will definitely form a set. So what type of collection is a set? Set is a well defined collection. Set is a well defined collection is a set. Or in simple words, if I say members a collection whose members or elements can be clearly and definitely decided. A collection whose members or elements can be clearly and definitely decided forms a set. So we are done with the definition. Next basic thing which we will learn is how to write a set. So before that, always for naming the set we will use a capital letter, and to denote the elements of the set we will use the small letters. And one more thing, when I write this way, this symbol means belongs to. That means A belongs to the set capital A. And when I write this way, what this will be? Does not belongs to. Yeah, does not belongs to. So this symbol means A belongs to the set capital A, and this means A does not belongs to the set capital A, or A is an element of A. Here A is not an element of A. Okay, so these are basic notations that we will follow whenever we are talking about set theory. Okay, next let's learn how to write a set. Okay, there are two methods of writing a set. The first method is roster method. This is also known as listing. Roster itself means listing or list. Okay, listing method. As the name suggests here, okay, consider the set of first 5 natural numbers. What are the first 5 natural numbers? In listing method, we just list out the elements. Which are the first 5 natural numbers? 1, 2, 3, 4 and 5. So we have just listed the elements. Now this I can list it in any order. That doesn't matter at all, because in any order I write, the set is the same. Okay, this order is not important. Only one rule is that we cannot repeat any elements in that set, and we should include all the elements, required elements of the set. That's it. Okay, we have to just list the elements, where order is not at all important. I will write it here. Let's name not N. I will use some other letter. Okay, this is how I wrote in roster method. Now same example. Okay, next method. Next method is the set builder method. Or in other words, it will be rule method. Okay, rule method. So here what do? We don't need to list all the elements. Here we will, I am trying to write the same set in set builder form. Okay, let's first 5 natural numbers. Okay, here I will use a letter to denote. It can be A, B, C, any letter I can use. It is not that here I have written A, so here I should use small letter. I can use any other. Okay, let's use small letter N. This is a general term used to express the elements of this particular set. Okay, so, and then I will write now a set of all such n's says that, now I will write the rule that n is supposed to follow. First 5 natural numbers, that means my n belongs to n. That means, okay, this notation we will discuss later. Here n is the set of natural numbers. Okay, so this is a fundamental notation used to express the set of natural numbers. It is a set of all natural numbers. Okay, and I will write n belongs to n. That means n is an element of capital N, which is a set of natural numbers. And one more thing is that first 5, I have to stop at 5. So I will restrict n till 5. So what are the rules it is following? It is a natural number. The second rule is it should be less than or equal to 5. So if I try to write, the elements, n is a natural number, it will start with 1. So 1 is less than 5, 2 is less than equal to 5, 3 is less than equal to 5, 4 is also less than equal to 5, 5 is equal to 5. So I have arrived at the same set. So this is using rule method and this is using roster method. Roster method means listing and set builder method means rule method. Set builder means using this form I can build the whole set. I know what elements will belong to the set. So a general term is used to express the elements of the set and I will write that elements rule that the elements should follow. It is a natural number and I want only first 5, so I have restricted it till 5. Clear? So these are the two ways of writing a set. Now as I said, this n denotes the set of natural numbers. It is a fundamental notation. So let's discuss few mathematical sets or set of numbers which have some fundamental notations. Okay, that means anywhere I see capital N and I'm talking about set theory, that means it is a set of natural numbers. So first is, these are fundamental notations. 1, 2, 3. Natural numbers means all counting numbers. Infinite, right? Innumerable. And next such fundamental set is a set of whole numbers, which starts with 0 and then same as the natural numbers. Next is the set of integers, -3, -2, -1, 0, 1, 2, 3, and from both sides will continue. And the next fundamental set is Q, that is, you have already learned rational numbers, right? In 6th standard you have already learned. It is a set of rationals. Okay, I'm not listing the elements because I can't follow any order here. So I will just write set of rational numbers. Now if you notice, using roster form writing or denoting set of rational numbers is difficult. But using set builder form we can definitely express this set. How? Simply using the definition of rational numbers. P by Q form. So Q contains all elements of the form P by Q such that my P belongs to I, my Q also belongs to I, and this Q is non-zero. This is just the definition of rationals. It is of the form P upon Q such that both are integers and this Q is non-zero, because if Q is 0 then this number won't exist. Okay, you already know this because you are acquainted with this definition in the standard 6th, right? Rationals. So this is the another way which I can write the set of rationals. It is P by Q form. P and Q are integers and Q is non-zero. Next is the largest of all. Okay, I'm sorry, here also I can't express all elements of, or I can't give it an order. So I will just write set of real numbers. Okay, it is union of all. Rationals, integers, whole, natural, all type of real numbers will come under this. All type of numbers you have learned till now will come under this. I think complex numbers are not learned by you yet. So these are the fundamental notations or fundamental set of numbers which we should know. N means natural numbers, W means set of whole numbers, I means set of integers, Q means set of rationals, and R means set of real numbers. And in this case, in some books we also find Z used in place of I for integers. Okay, so I stop with this video, and in my next video I will be discussing the practice set 1.1. Stay tuned.